In this video, let me consider a numerical on Fourier transform. Obtain the Fourier transform of the following signals: sketch, magnitude and phase spectra. Here the time domain signal x of t is given. We are supposed to find the Fourier transform of these two signals. Let me consider the first signal. We know that the Fourier transform of any continuous time signal x of t is represented as x of j omega. Here x of t value is a when t is in between minus t to t and its value is 0 otherwise. Let me draw this signal. So x of t looks like this. So let this be x of t and say this is minus t and this is plus t. Its value exists only between minus t to plus t and its amplitude is a. Say this is t. So this is the representation of x of t signal. We know that the Fourier transform of x of t is x of j omega, which can be represented as x of j omega is equal to integration minus infinity to infinity x of t e power minus j omega t into dt. So here we can say that x of t value is a, that is amplitude is a. So I can represent it as x of j omega is equal to, here x of t signal exists only between minus t to plus t. So it is minus t to plus t. X of t value is a e power minus j omega t into dt. So now let me simplify this further. I can represent here x of j omega is equal to, here a is constant, keep a as it is. Integration of e power minus j omega t is given by e power minus j omega t divided by minus j omega, and the limits are minus t to plus t, that is minus t to plus t. Let me simplify this further, or I can represent it as a, that is replace t by this t, that is e power minus j omega t divided by minus j omega. So now replace this t by minus t, that is minus e power minus j omega t, that is it is minus, so it will become plus, divided by minus j omega, or I can simplify this as a in bracket. So this term will be positive. I will represent it as first, that is e power j omega t minus, here we have e power minus j omega t divided by, it is j omega, or I can represent it as we know that sin theta can be represented as e power j theta minus e power minus j theta divided by 2j. So I will try to express this expression in terms of sin theta, so that I can represent it as x of j omega is equal to a. So here comparing this expression with this, theta is nothing but omega t, that is e power j omega t minus e power minus j omega t divided by, here we have 2j, let me write it as 2j. So to compensate this 2, I will multiply here with 2. I will take this omega outside, it will be omega. So this is same as this one, therefore I can represent it as x of j omega is equal to, that is we have 2a by omega, 2a by omega, and here we have sin omega t. So thus this is the Fourier transform of the given signal x of t. we'll call it as equation 1. We know that we have a function sinc x which will be equal to sine x divided by x. So now I can try to represent this expression in terms of sinc x, that is x of j omega is equal to 2a sine omega t divided by omega t. So to compensate this t, I will multiply this with t, or I can represent it as x of j omega is equal to, I'll take this 2a into t, we have sine omega t divided by omega t, or I can represent it as x of j omega is equal to 2at. Here it is of form sine x by x, that is sinc x. I can represent it as sinc omega t. So this is true when omega is not equal to 0. So here if omega is equal to 0, so in this expression if omega is equal to 0, it will be in indeterminate form. So by using L'Hospital rule, we can read L'Hospital rule indicates that is limit alpha tends to 0, sine a alpha divided by alpha will be equal to a. So similarly, if we apply L'Hospital rule here, that is here we can see that sine omega t by omega t. So omega t is nothing but alpha, a value is nothing but 1 here. So sine omega t by omega t is equal to 1. Therefore, I can write x of j omega value will be equal. Therefore, I can write x of j omega is equal to 2at. This is when omega is equal to 0. Now let me draw the spectrum of x of j omega. So this is the spectrum of x of j omega, that is plot of x of j omega with respect to omega. So here we can see that at omega equal to 0, the value of x of j omega is 2at. That is at omega equal to 0, the amplitude, that is 2at. And here we can see that these are known as zero crossings. So zero crossings are calculated as, here we can see that sine omega t by omega t. So at zero crossings, x of j omega value is 0. That is sine omega t by omega t is equal to 0. That is sine omega t is equal to 0, or we can write at every omega t is equal to plus or minus n pi, the sine omega t value will be 0, or we can write omega is equal to plus or minus n pi by t. The omega for these values, the function, that is x of j omega, will be 0. Here n is nothing but integer, that is 1, 2, 3 and 4 and so on. Therefore now I can represent it as this is, so at omega is equal to 1 pi by t, that is I can represent it as n is equal to 1, that is pi by t. Similarly this will be 2 pi by t, and this will be 3 pi by t, this will be 4 pi by t and so on. Similarly on left side we have minus pi by t, this is minus 2 pi by t, this will be minus 3 pi by t. At these omegas, x of j omega value will be 0. So this is the graph of sinc function, or so here we can observe that this is the main lobe, that is at omega equal to 0, will get the magnitude or the amplitude will be very high, that is 280. So this is known as main lobe and these all are side lobes. Here as omega value increases, x of j omega will approaches to 0. Now let me draw the magnitude spectrum. So magnitude spectrum can be obtained as, that is x of j omega. If we take the magnitude of this, we'll get, that is magnitude of 280 sinc omega t, that is magnitude of 280 sinc omega t. So if we take the magnitude of this x of j omega, we can get the graph of that looks like this. That is, here we can see that at these all things, these side lobes will if we take the magnitude of x of j omega, the all side lobes which are negative values will appear on the positive side. So the magnitude spectrum of this x of j omega looks like this. So here this was the negative side lobe which is on negative side, which will appear on positive side as shown here. So here this is 0, this will be pi by t, this is 2 pi by t, 3 pi by t, and so on. Here it is minus pi by t, this is minus 2 pi by t, and so on. So this is magnitude spectrum. Now let me draw the phase spectrum, that is phase spectrum. So in this expression we can see that there is no j term. So for the main lobe, the value of phase spectrum will be 0, that is angle of x of j omega will be equal to, that is nothing but theta of omega is equal to 0 for omega is equal to 0 and its value is minus pi when the sinc function, that is sinc omega t value is less than 0 and omega is greater than 0 and its value is plus pi when sinc omega t value is less than 0 and omega is less than 0. The phase spectrum looks like this. Here we can see that the phase spectrum, that is x of j omega, that is theta of omega 0 for omega is equal to 0. So here its value is 0 and its value is minus pi when sinc omega t is less than 0. So here we can see that the sinc omega t, here it is less than 0. The magnitude of x of j omega for this portion, that is pi by t to 2 pi by t. So this is the phase spectrum. So this will be pi by t, this is 2 pi by t, this is 3 pi by t, and so on. Here it is minus pi by t, minus 2 pi by t, and so on. Here we can see that for omega greater than 0 the value will be minus pi and for omega less than 0 the value will be plus pi. Now let me consider the second example, that is x of t is e power minus a magnitude of t, assuming a is greater than 0. Let me draw the signal x of t. It's an exponential signal. This is positive axis of t. Let this be negative axis of t. This is 0. So for positive values of t, the signal appears like this, and here the magnitude will be e power minus 8 ATU of t, and for negative values of t it will be looks like this. Here the magnitude will be e power t is minus, So minus minus will be plus a power t u of minus t. Now we'll try to find the Fourier transform of x of t. We know that Fourier transform of x of t is represented as x of j omega. It is given by minus infinity to infinity x of t e power minus j omega t into dt, or I can represent it as x of j omega is equal to, we have here, we can see that from minus infinity to 0 this signal will come into the picture, and from 0 to plus infinity this signal will come into the picture. So now I can represent it as minus infinity to 0, the signal is e power at into e power minus j omega t dt plus, and from 0 to plus infinity, that is 0 to plus infinity, the signal is e power minus at u of t, that is e power minus at into e power minus j omega t into dt, or I can represent it as x of j omega is equal to minus infinity to 0. I can represent it as e power t a minus j omega dt plus, similarly I can represent it as 0 to infinity e power minus t a plus j omega into dt. Now let me simplify this further. Let me continue here. So integration of e power t a minus j omega is x of j omega is equal to, this will be e power t a minus j omega divided by a minus j omega. The limit will be minus infinity to 0 plus, we have integration of this is e power minus t a plus j omega divided by minus a plus j omega. The limit is 0 infinity. Simplifying this further, x of j omega is equal to, substituting t equal to 0, its value will be 1 divided by a minus j omega minus, we have e power minus infinity, so e power minus infinity is 0. Similar plus, here substituting t equal to infinity, e power minus infinity value will be 0. So now minus of minus, so now here plus, so e power minus infinity value will be 0 plus, so minus into minus will become plus, so substituting t equal to 0, it will be 1 divided by a plus j omega, or we can represent it as x of j omega is equal to 1 over a minus j omega plus 1 over a plus j omega, or simplifying this I can represent it as x of j omega is equal to, so here taking the LCM these two terms will come here, that is a minus j omega a plus j omega, here we have a plus j omega plus a minus j omega, it can be represented as 2a divided by, we have a square plus omega square, that is a plus b, a minus b form, that is a square minus b square, that is j omega, j square is minus 1, so it is a square plus omega square. Therefore x of j omega is equal to 2a divided by a square plus omega square. This is the Fourier transform of given signal x of t. Now we'll try to draw the magnitude spectrum, that is magnitude spectrum, that is magnitude of x of j omega is equal to, we have 2a divided by a square plus omega square, its magnitude. So here at omega equal to 0, the magnitude will be a will get cancelled, will get 2 by a. So let me draw the magnitude spectrum. X of j omega, this is omega. So at omega equal to 0, if we take omega equal to 0, it will be 2a divided by a square. So the magnitude is 2 by a. So as omega increases, this value will be decreases like this, and as omega increases in negative side, the value will be decreases like this. So this is the magnitude spectrum, and the phase spectrum, that is angle of x of j omega. Here there is no any j term, so the angle or the phase will be 0. There, as there is no any j term, or it's a real function, so here it is a real function, there is no j term, therefore the phase spectrum will be 0. That is, we can represent the phase spectrum, or we can show the phase spectrum as, this is theta of j omega, or angle of x of j omega. Its value is 0 everywhere for all values of omega. Thank you for watching.